Thank you everyone for joining the office hours. It's been a while since we had one of these. And um, let's see if we can get him to join. We sort of each office hours we kind of have try to have a theme about kind of what we're going to talk about or what it's going to be. The last one was actually recapping 2024. We can't really do that yet because we want to for 2025 as we want to save that topic and theme for the next office hours, hopefully. So we came up with the four E's of ML and microscopy, the four E's being evolution, expansion, exploration, and experience. If you are any board game geeks or board game fans in the group, you will maybe possibly recognize or know what 4E is. That's what it's sort of an homage to in that one. But we found that those four E's for board games were a little more intense and than what we wanted here for this. But we've got this kind of the topics and theme that we're going to go through is talk about the evolution of the user interface or the user experience. So it's UX. We'll highlight some of the features that I've been asked about and going on from there that we've added since the last time we had the office hours and have been pushed out in some recent releases. We're going to talk about our expansion into NDT, which is non-destructive testing, another use case that we're going to bring on online, and so talk about how there's a lot of similarities between NDT applications and use cases and microscopy. We'll talk about that. We'll also go into exploration. This is sort of experiments and stuff. We recently published a paper with Columbia University where we compared YOLO V8 to UNEP, but we would love to hear what other kinds of experiments are being done and other papers that maybe have been published using ML and microscopy and specifically in materials or NDT or others along that way. And then experience. So we want to call out, we'll do it very early, but we'll also do it at the end again, that we are a sponsor of the AI and ML for Microscopy Hackathon. This is their second one that they are running. This is mostly run out of the University of Tennessee, but there's a couple of people on here that also are going to be participating in that. We are a sponsor of it, and that's sometime in December. We've got more information for that later, but that's an experience that everyone can join and such. They had their launch meeting this morning. You still time to join that if you're interested in going on from there. So some significant new features that we've added since the last time we had office hours and some that we just kind of want to highlight, and we'll also do a little bit of a demo on these is YOLO E. We've added the YOLO Everything model published by Ultralytics that has native support on the Theia scope. You can use it in a prompt or prompt-free option. There's multiple rulers have been added. So this is for metrology and the NDT space, but also being used in microscopy to measure distances or lengths or any kind of dimensions within the vision panel on any of the dashboards that have that. Themes have been added. I've been using the desert theme because that apparently is easier to see in recordings and to see my mouse move and such, but they have a variety of themes available now in the dashboards. My personal favorite, though, is the Tron one, but that's just me. But you're more than welcome to take a look at those. Again, it's more than just light and dark mode now. There's different kinds of themes associated with that. We also added delete and ignore annotations. This was actually a request from a couple of users to be able to manage and filter and screen annotations within the examine dashboard and such on that. So that was a community request, and we've added that in. We also have enabled, this is another community request as well, but I didn't put the little thing underneath of it, but this is tiling support for the Detectron 2 models. So these would be the fast, faster, and mask RCNN, and we'll see that a little bit later because that's really important for getting small object detection, which we know a lot of people are trying to do. And that's also useful for YOLO. We've had the tiling support for the YOLO V5, V8, and V11 models, and this now adds that similar support for the Detectron 2, specifically the mask RCNN models that we know the microscopy community have been using out there. We also, a couple months ago, introduced a new tiler. This is what we're calling MIST, or Emerging Instant Segmentation Tiler. Mist is a little bit more adapted for small object, but also large object instance segmentation. So originally, up until about 2 months ago, the Sahi tiler really didn't do instance segmentations. It was more about bounding boxes and doing that. They recently now have added that support along with the Detectron 2 support. But in that time span, we looked at that and we said, well, there might be some ways that we can make it a little bit more efficient, and that we could also, we were running into issues where objects that were spanning tiles were getting counted twice or multiple times, but then other objects that were instance segmentations were not being counted. So the mist is sort of an evolution of that, and it comes out of that. It is still a work in progress, but we have used it on very large format images with objects that span multiple tiles. It will sort of reduce those down or merge those instances together into a single instance, so you're not double or triple or quadruply counting. And then we've added better exporting and quicker exporting, both in the CSV and Excel spreadsheets, and also Google Sheet export. So we had one use case, an example where client wanted to export their results into Google Sheets, and we created a nice like report from that, and it happens sort of kind of all automatically whenever they hit the snapshot button. So that was a really cool sort of automation and integration feature that we were able to add into all of this. And then of course, that I mentioned, we published this paper in APL machine learning. This is with a collaboration. We worked with Columbia University, Katie Barmack and Matthew Patrick on that paper for about a year and a half, roughly. So we were actually pretty proud of that because that was a pretty quick turnaround on that. They had been building out a bunch of UNet models for their grain boundaries. And so this was a new use case for us as well. And I looked at their images and I said, hey, maybe there's something we could do there. Wouldn't it be cool if we could run your models or a YOLO V8 model in real time on a microscope and look at the grain boundary evolution and grain size distributions over time? They said, yeah, that'd be pretty cool. Let's do something. And so we ended up creating this publication, and we were very happy about that. We would also love to write a similar paper with anybody who is on this call. So if you are interested and want to do that, that would be fantastic. We would love to do that. We can also work with you to deploy a system for the paper we're testing, develop new models, develop new computer vision, machine vision algorithms or workflows that could be used in your with or without a Theoscope and be used to publish a paper in that. We can also, we did quite a bit of writing for this one as well, so we have experience writing papers and submitting, so we can help with that. But I think what we're all here for, of course, is to do some, see this thing in action and live demos. We'll see how this goes. So the one that everyone's been kind of, I keep getting asked about, and I have no problems being asked this, but I thought it would be great to just highlight specifically that while we originally focused on doing real-time analysis and doing this on a screen capturing situation, we do have the ability to run models and to run batches of images in the background or overnight or over time. And so this can be done with either zip files or archive files, videos, or multi-page TIFFs. So we've added support for multi-page TIFFs. And the process is very similar to doing an acquisition. You kind of have two different ways you can do this. First thing we want to do is spin up a model. I'm going to spin up the Detectron 2 mask RCN. Oh no, this is the YOLO V8. So sure, we'll spin this one up instead. This is based on the same data set for the mask RCNN, but it's a YOLO V8 one that we've trained, and it's an S segmentation. So this is starting up the actor. We'll just start up one. I'm on a Theoscope S. You might be able to see one over my shoulder situation. So we're just going to have one model. We could have done multiple models. If you're able to run multiple models, you can spin them all up. The process is more or less the same. So we have two options now at this point. We can either start a job here by going to the media panel in the job panel, and we can upload. So we can say like add a file, and give me 1 second to pull up a zip file I thought I had this already loaded, but of course I don't because that's just the way this works when you're doing it live. Go to the here, and what we'll do here is I created a zip file with 3 images, so this is going to go pretty quick, but you can upload the file. Oh, that one already existed. So we've got that protection in there, so that's great. So that's already down here. I'm going to delete it, and we'll start it all over again to kind of show the whole process just in case. So we'll go add file, go cavities, drag and drop. It will upload that one, and any models that are idle, it will run and it will start the background job. So now it is unpacking that zip file and it's running all 3 images across the models. If it was a slower or you had more images model, we could go here and we could see the progress and we can monitor the progress under the Analyze tabs. This has been completed. We have 2 options. We can go to the calendar and we see we have our 3 and we can go to our examine dashboard, but we also have a shortcut here that will take you immediately to that those 3 images that we did the analysis on in that case and jump you straight to it. So here is those images. Some of these might look a little familiar because this is again coming from that data set from Wisconsin on cavities and TEM images, but we're able to then go directly to that. So that's one way you could do it. It's starting up the model. Any models that are idle when you upload the file will automatically be used to do that analysis. If you had multiple models, they would all be used. The other way you can do this, though, is if you've already uploaded it, we can go ahead and hit play. And we can go down here and say, analyze this media. And now we have, this is a newer feature that we've added, is this sort of preview window. And this allows you to select a region of interest within all the images. You can also cycle through just to check to make sure that all your images are going to be lined up in that situation. So a little bit like the acquisition dashboard, you're able to kind of put this together. And you can also do full screen, which we'll of course do. The other option you have here is you have multiple models, you can select which one you want to run as well. So if you have 3 of them, but you only want to run 2 of them at the same time, you can select them and build up a list of all of them. But if you leave it empty, it will use all the ones just like the other one in there before. So let's click analyze and cross our fingers and hope this works. This time it's analyzing, we've got a progress. It's going from pending to running. We'll then see it and now it's done. It is just that fast. And now we have 6 more images, but we can click on here and it'll be the next 3 images that we had running on there in that process. We also, of course, have a third way of doing all of this because we cannot do it just one way or 2 ways, but I'm going to delete that. We can go to the acquisition dashboard and we can upload our zip file directly here as well. And this will start that as an upload and then we'll start the model running and it will start an analyze job in the background. So you can see it was processing there and it will update this over time and we will see those things work as we go through them. So now if I go back to my home dashboard, I can go back to the analyze. We see we have our third analyze job that was running in the background for that process. It's a little fast, so the acquisition dashboard didn't pick up all of them. But the thing to note about a zip file versus like a video or even a multi-page, well, not the multi-page diff, but a zip file versus a video is the zip file, it's going to do every single image, right? And it's going to do them at the resolution of that image. If you upload a video, it will do every single frame in that video. But if the video has any kind of compression or encoding like an MP4 or something like that, it's going to lose the resolution in that process, right? But it may still be a higher resolution and be more of the images than when you're doing a screen capture. If you're doing a screen capture and streaming the images, it's not doing every single frame. It's doing however many frames per second you've configured it to do it for. So you might be missing some frames. So that's kind of the difference though between also running a background job and then running a stream. The other thing is a background job may take longer because it is doing all of the frames and all of the images in sequence and in series, as opposed to like in parallel or skipping some of the frames to keep up with the live feed situation. So that's really briefly how to do background jobs though, and you can upload gigs of them and run it from there. Then you also have the media, and you can organize things into folders, move things around, delete the files, organize this however you would like in that process. And again, all of this applies to multi-page TIFFs too, which at least in electron microscopy, we haven't run across too many of those, but in optical microscopy and bioimaging, multi-page TIFFs are definitely used quite heavily. So that's something else to keep in mind in all of that. The file formats that are supported within the archive files and subfolders are supported in archive files or zip files are the same ones that are supported, of course, in the front here. So this includes your BMP files, your DM3, your DM4s, your JPEGs, your TIFFs, your PNGs, and then the videos are .mov files, .mp4s, and AVI files. The AVI files, though, that is a container format, so it's very hit or miss, right? It all depends on what the codec is being used for those and all of those processes. So we do support the file extension. Can't guarantee that we support every single AVI file that is out there on the planet, but neither can Windows. So I think we're in okay company at that point when it comes to that. So that's one of the features that we were working on and that we've really sort of updated that. We have a drawer that comes out now and everything else. Some of the other features we wanted to highlight as part of that experiences and 4E situation was the rulers. So I just wanted to kind of show this as an example. So we can say, clicked on this, we can add the ruler. And if you have scale bars, this will be in the units that you're looking for. So we were able to add one scale bar in this case, and we can zoom in, we can look at sort of what's our dimension, but people were having to then move this one here and kind of go through each one sort of manually to look at that. Or if you're looking at the distances, you kind of had to do them one at a time. We've now added the ability to go through and do this and have multiple rulers. And so you can keep adding rulers until your heart content situation. You can also right click and you can change these and make these different colors so that you can change them, and you can then make it easier, like, oh, the blue one is doing this sort of situation. We have a very Google-esque set of rulers here, but it is what it is. You can also then go in and you can remove these if they're getting in the way. The rulers also have the ability to something else that we added in there. If you go to measurement and go to ruler, we've had it so that they will now snap to various points. So if we have sort of, for example, our centroids, we turn that on, we can take this, you can see it kind of snaps to the location for it. So I'm going there, and we can change that distance if we got it too big to make it a little bit easier and such like that. So you can snap them to different points on there, making it very easy to measure this situation. Then now what's interesting too, though, is we wanted to measure the distances of all of these. You still have to do it manually, you have to do it with the multiple rulers, but something that we just released today and is in the works and available for others is we can measure these distances automatically. And we've added this distances button, and we just put it up there, and we get the triangulation information from there automatically. And that now also has the various sort of, we can make the fonts different sizes, we can make them bigger and smaller, we can make the line thicknesses and all that situation. We can also color code them as well, just like we have for everything else when it comes to the thing. And that's simple as a toggle in that case. And we can go ahead and do that. We can also, of course, export all of this information. If we were to do a bulk export, you will now see that there's this, well, most of you will see this, distances, and it'll say enabled. You can enable that, and it'll output all of those distances in a CSV file so that you get those all automatically, hopefully minimizing the amount of manual measurements that have to be done for all of these systems and all those processes. So that was a process, and really cool that we could do that. So I'm going to go ahead and let's just export this. And so this is going to do an export all and download on that. While it's doing that, I'm going to take a moment to breathe and see if there are any questions, comments, complaints, concerns. I'll take silence is that it's perfect and there is anything that ever needs to change. But we can see here that, of course, that we've got now our distances and we've got our measurements and we've got the YOLO text file format for all of the annotations. And we have our now classic TSPNG file for all of that. We also output now the model that was used. So you can easily upload this and use this. So this is a way to transfer from one Theoscope to another or share with collaborators. We also have this data config file for those of you who are familiar with training sort of YOLO models. That's available, and this is the YAML file for training that. This makes it easier to upload the the data and the exported values as inputs to the next training event situation. We can also see here, let's see if this works. Sure. Uh, oh, it didn't work. It does work. It didn't work though. Ben and I have been working on this. I forgot to check a box, which always happens. If we go down to distances, I want to say I want to use the centroid, and then we'll get that. Because in addition to centroids, we also have added in recently extreme points, which is the leftmost and rightmost points, and topmost and bottommost points and all of that. So you can see we have now these expanded points. If we make these a static color, it's a little bit easier to kind of see those points then. And if we change to the bounding boxes, we can kind of see we've got our centroid and our extreme point. So that if you're trying to if you're using the maximum width or something like that, of course, the rulers will snap to those, and then that makes it easier to measure those kinds of things as well. So there's a variety of new features, a lot of features that are sort of, I don't want to say hidden, but are in there that we've added since the last time that we got together and had a conversation. So now with that export done, hopefully that means then we've got the distances in there. So I also have our meme generator in here with the GIFs being exported as well. So we've got that. We go here and we see that we now have, cross our fingers, hey, this is going to be good. We've got our distances and we have them in the CSV format. So they are also in your engineering units, the normalized units, and in pixels, depending on what you're dealing with and what you're looking at. We also have the endpoint and the start and stop point for each of those distances as well. We say what the label is. We've got that. There's also the tracking ID for each of the objects that are the start one, and if you're using a tracker on all of this. So all of that information is being saved and is being outputted in the system now, so that you can get a huge amount of dump of data that you can then use either with our system furthermore or with other whatever workflows you're looking into and wanting to use. Maybe you're also using onboard Jupyter notebooks, and that would be another way that you can get access to that information for all of that. So let me jump back over here. Okay, I didn't want that, but that's fine. So that was the demo. So a couple of features, just a couple of things. We had our latest release. I just showed some of these. I talked about them with the distances, the tiling for the Detectron 2 models, and the YOLO E. Those are sort of the high points and the ones that we've released actually over in the last couple of months and the last couple of releases. So we're fairly excited by those new features, but of course, there are a whole bunch of other features and other things on there. So let me know if there's something else that you're interested in seeing or have questions or problems. So I will pose this question to the group then. What are you hoping for that TS and machine learning can solve in your workflows and in your responses? So you don't have to answer it right now, but just something to think about, and you can go ahead and put that in there. So the other thing that we wanted to sort of talk about and show was a new use case, which is what is these turbine blades. This is an X-ray image, and this is for non-destructive testing. And so we were able to put this together me see if I have this up and loaded. So for another potential client and use case is using X-ray and digital radiography and doing the identification of that. Now, one of the interesting things about this is that it's actually a very similar sort of, or I should say, there's a lot of similarities between NDT and microscopy. A lot of times they don't have a large public data set that they can build their models from. Whereas in microscopy, maybe you only have 10 images for that one particular sample situation. So you still have this sort of like minimal training set. So all of the workflows and all the work that everyone on this call has done to sort of make microscopy models work can be applied to the NDT case. And all of those rulers and the measurements and the particle analysis stuff, the morphology, all of those things are also useful in the non-destructive testing case. I have to remember where I put that dashboard. And I think I put it right here. So maybe I've done that. Hey, there we go. But it's in the light mode. So here, what we've done is we actually created a model and trained a model. It's a TS YOLO model. Some of you can see the sort of information there about it. Oh no, it's down here. It's an M medium size. This one was only 100 epoch though. So this was just to sort of test to see what would happen and kind of go from there. But they were trying to find the defects. What's interesting about this is that a lot of the defects will light up very easily in the NDT or X-ray images, where in in microscopy, sometimes they're a little more nuanced. However, there are other parts in NDT that are nuanced, and they use a lot of contrast stretching and other image processing algorithms in order to sort of elucidate those detections manually and such. But we built a dashboard here as an example. The other thing that with that minimum amount of data that's available to train the model with, we've created simulated images, which I know many of the people on this call in the University of Michigan have been playing with and working with simulated images for microscopy and electron microscopy. Well, we can do the same thing with X-rays, right? So we found an X-ray part simulator. Sai, who's on the call, is a CAD specialist. So if you have any CAD questions, you can talk to him about it. But he was able to design this airplane wing parts essentially for the aerospace, and then we simulated what it would look like under an X-ray, and then we used those simulated images and we created simulated defects in them. That created a training set. We then trained it with TS YOLO and created this YOLO model, uploaded the weight file to here, and then we were able to apply that model and build this dashboard. And then one of the interesting things that the NDT spaces, they really want a green light, red light sort of situation. They want to know, is this a bad part or a good part situation? So we've started adding a bunch of features then into the various panels that are available to everybody. And one of them is like color coding based off of a certain criteria. So anything that's over, I believe 70 here is going to be yellow. Anything over 600 is going to be red, as an example. And this way, the operators can look at it and immediately see which of these defects and which of these things are above a certain criteria, or overall, we can do an average and say, is this a good part or bad part in this case? And so the other thing is that we could then download these tables into into a spreadsheet, either download it as an Excel file or as a CSV file, but we can also export it as a Google Sheets. I didn't have time to set that up on this particular system, so I won't be able to show that, but it is available and it's something that anybody can do. It takes a little bit of configuration. If you go down to here and we go to, I forget where, yeah, advanced, there's external export. And then you have to choose which of, you have to kind of go through all these different sort of processes, but we can go here and we can build this out. We are more than happy to help anybody set the site integration up, however you would like. It does require some tokens and access on the Google Sheet side of things, but it does work really well for putting all that information together in there in that process. So that's something that we found that was useful in the NDT space of using this new and different use case. But there's actually quite a lot of similarities across everything for that. So we're really happy to start expanding out into other areas. So I'm going to open up the floor and take another moment to hydrate and leave it sort of up here as some open for discussion. Is there any sort of problems that people are encountering that they would like us to help with? More than welcome to do that. If you want to, if you can, if there's some images you want us to try to analyze during the time, we are more than happy. They have to be publicly available though, but we can go ahead and do that too.
Hey, Chris. I was interested because you mentioned that you were the cystoscope have the Sahi function right now. So
Hmm.
basically, if I have an image with a regular size feature, but at the same time have also a lot of very small, tiny uh, features, and then for example, right now I'm working on those cavities, but the sample is being implanted with helium, so they are also small bubbles, right? And then
Hmm.
I just apply my Detectron 2 model, and then it's not very working very well. And then
Yeah.
so I'm just curious, how do you implant that in your platform?
Yeah.
Just yeah.
Yeah. Let's do it. So we will go here. I'm going to spin down this model and we will, let's see, let's go to reuse, search. All right. Let's see. That was half a GPU, so we'll use the full GPU. So this one here is the mask RCNN model. The same is true in the same. It's the same process if you're using a YOLO model, a V8 or a V11. But the mask RCNN, you mentioned Detectron 2. That's what this currently supports, and that's what we're running in the background. But we see here that you'll go down to tiling and it will be down here and you can just say enable and it will be enabled and it's the Sahi and then you can adjust your sort of overlaps and all of your other sort of configurations and such on there. For the small objects, you probably really want to drop this confidence threshold down quite a bit. It's usually defaults to around like 20%. We made it so that you can go to even lower values between 0 and 1% on this. Um, so you because as you get the small, even with the Sahi enabled on there, it's gonna be kind of a challenge for it to get those small objects because there's not going to be enough visual information, right? If you're talking about like 4 to 8 pixels, the model is going to have a struggle with that. So it's going to have low confidence on that. So one thing you want to do is add that in there, but you turn that on, we hit start, and this will spin up this model. Um, let's see. Justin, is it okay if I use some of your images?
You mean my images?
Yeah,
One of
go
the,
ahead. Sorry, I was trying to find the unmute button.
yeah, yeah. So I just know Justin and I have been working on this, and I've been trying to get him, unblocked in a sense from this, but he has some, we'll call it, well, this is a DM4 file right, that has these cavities, right, that are very large, but there's also a lot of small ones in there. So we're going to go in, and this is a Tectron 2 model. This is with the Sahi on there, and this is his sort of um, configuration on here. But I think this is similar to what you are trying to do and looking at doing for there. You do
Yeah.
notice, though, it slows it down, right? Because you're chopping it up into smaller ones. So instead of doing one inference, you're doing, uh, 10 inferences for per one image because you've chopped it up into 10 or 9 different tiles in this case. Hopefully this doesn't completely bomb on me at this moment. This is a larger one. We did, this is a DM4 file. I think we did convert it to a TIFF. I just can't find it at the moment. Um, or into a JPEG, which would help with the analysis on it. But we'll eventually get there because in this image, eventually you can do it, computer. You can just see it is taking a lot longer. It is also the mask RCNN, which is a slower model. And then when you drop that confidence down, you're definitely getting a lot more objects. And so we have to handle a lot more on there. So this is an excellent use case for the background jobs, not for a live setting. but we did get 827 objects, and it will show them here in just hopefully a moment. Let's crank this down. We don't need to be constantly showing or updating the interval. Hey, there we go. So we were able to get the smaller objects then in this, right? It's getting the smaller ones as well as the big ones for this. And it might be a little bit faster if we turned on the bounding boxes. Yeah, maybe not. I don't know. Let's increase the size here. Makes it's a big image, so because these are, I believe, if they're not 4K images, they're at least 2048 by 2048. So
They're
the
4K.
image, they're 4K, yeah. So even that. So right, they're 4K DM4 files, and we're trying to get the multi-scale and multi-size, but it is doing it. It is working on it. Now, some of them, it's picking up, we'll call them inner cavities, right? But that's something that the models can work on, and we can also playing around with that IOU might help with in that case. But that's how that's pretty much it then for using the Tyler with the Detectron 2 model.
Well, this
So
is
if
a
you have,
good, yeah.
yeah, yeah, um, and yeah, that's it. You can also run this in real time on the microscope too. Um, you enable the tiler, it will handle it, but it's going to be a little bit slower. So I would recommend using one of the YOLO models because that's just going to be faster. And if you're doing it in real time, maybe the bounding boxes is enough. But we do know, and I don't know if there's a way around this. It's something that we are constantly struggling against where when you get up above about 300 objects in an image, things just start to kind of get bogged down. So if you're getting 300 plus images in real time, things are going to feel a little sluggish, but at least you're getting it at the microscope situation. But that's sort of one part of the process there.
I see. So recently we are also playing with the Detectron 2 model and then and use the mask to former method
Oh,
to
okay.
also try to get a smaller feature. But we found that it's strange that if we just apply Detectron 2 model, then some feature is being segmented okay, but then after you apply that slice over, some of the
Mhm.
object will be divided into several pieces. But it looks like you don't have that problem here.
No, we don't really have that problem. That's partly because we're sort of biasing it a little bit, and Justin has also done quite a bit of work of tuning those parameters on that Detectron too to get that to work. So I don't want to discount his work and the effort that they've done on that. Um, but yeah, we don't quite have that sort of issue. But again, when you're running it in the background, we when you get to the YOLO though, one of the things you'll notice is that it doesn't look as nice, right? It doesn't have the
Yeah,
same pixel resolution. So we are thinking about ways of doing that and possibly better, either by changing the Ultralytics YOLO architecture to not scale down and scale back up and use a better interpolation algorithm there, or possibly just get the bounding box, use that as the markers for like a SAM or some other post inference analysis, like a watershed or some thresholding within each of the bounding boxes to get that could be faster and still get a better resolution in that regard. But then to do that within the tiler as well, right? So we're thinking about ways that we could do that because do you want to do those sorts of things on a per tile basis or do the reconstruction and then do it over the whole image? You probably want to do both and then see which one gives you the best result in that case. But that's a lot of more computation that would possibly need to go in there, which could slow things down a little bit. Yeah. As Kevin mentioned, I'll just call it out in the chat. They do run the Asahi as a background, and we are looking at doing a dispatched uh, tiling. So instead of taking each tile and sending it one at a time to inference, taking all the tiles, you can run multiple models. So we could dispatch and send all tiles to multiple models simultaneously and have them all come back and then do the reconstruction from there. So we're kind of doing a multi-model sort of situation. That is in the works. That is something we are actively putting together, and it is a large part of in focus over the next 6 months to put that sort of stuff together and to get that implemented. So another point for the tiling that could speed things up as well.
Okay, thank you.
Yeah. Any other questions?
I actually have a couple questions, comments, and thoughts.
Yeah.
I know I sent you a picture, but we can go over that last. But when using the Theia scope recently with the preview menu, because I've typically been doing the zip method because I have so many images I've needed to analyze. I'll open them up, and in the preview window, I think it'd be helpful if there were like I don't know how this might work, but an automatic scale to the width of the image itself. Because sometimes when I click and drag it, it like all the way to the edge, it will lag back maybe 10 to 50 pixels sometimes, and it'll take like two or three times. And if that could
Mm.
get so that would be helpful because I want to make sure I get every every pixel in the image analyzed.
So you're going in like this and you're going like that,
Yeah,
and
and then
it
I'll click and
doesn't.
drag out, and it won't quite get all the way to the edge, and sometimes it'll take a couple times for me to get it all the way out.
Yeah. So you could also click this button and that will go full screen.
Oh, perfect.
So
I didn't see that one. Perfect.
yeah, so it's right there. But we just saw up there that kind of worked. That gets you to the corner, but then yeah, so there's a little bit of flakiness, right? Because going here and yep, there, it's not quite getting all the way to the process to that. So that's probably well, inside baseball fabric JS problem that we'll have to put in there. So we'll create an issue in our tracker and get that fixed.
Awesome. Another thing too, with
Yeah.
regard to exporting, the export all is pretty helpful, but I know I was having issues with the 2K Sahi. I sent you the JSON for that. I know we've been talking about that ad nauseum for a while, but sometimes I'll like, let's say I run a zip file and it crashes, and then I run it again and it works. The export all can be a little finicky sometimes because then it'll export the whole batch like in a particular time frame.
Hmm.
I think the export all is a perfectly wonderful feature, but if there was like a way to export by particular file type rather than by time, because sometimes it can be a little tricky
Mm.
um, to pick like which ones I was trying to analyze, because a lot of the output looks very similar. I just didn't want to mess up any potential data analysis that I might be doing.
Yeah. So we have this option here in the export tab. There's the bulk export, which is a slightly different location. And it's slightly different. So you can say over a time range, but you can select it for a particular model instead. So you can say, I want to export all of the things for the Emily JHU and the Mask RCNN over a time range. But now doing it over a specific file name or file type is a little bit of a challenge, because in the real time, we don't have a file. Right. So how do you sort of say what do you want to do from the exporting? But I think what you're looking for is to export and filter based off of the origin of the files, right? So you could say I want to export everything that was from the cavities.zip file or everything that is a DM4 file. Is
No,
that what you're?
I think what Justin, correct me if I'm wrong, Justin, right, is that you're requesting to export by job, right? So you run one background job on a single zip file, it fails. You then restart a new job on the same zip file. He just wants to export from that new job, right?
Yeah,
So
pretty much.
yeah, so if you go back to the view that you had before, Chris, which I think was the one of the export batch, bulk export one, right? If there was a drop down above time range, which was by
Mhm.
job, and you just selected it and it listed out that kind of time range, then it automatically
Oh,
populated, that would be super helpful, right?
Yeah, that's
so
exactly what I was thinking.
Right,
okay,
because the
yeah, yeah.
parameters, the models and the parameters are all the same. It's just one failed job, and sometimes it's hard to remember. Oh, I started this one at 8 a.m. or whatever UTC code you're using as part of
Right,
it.
right. So I like this, and thank you for the suggestion. What I think I would add to it that if this one had failed, that there was a replay button, or so that you could see in the export and just click on this one and be like redo the export, right? Or just because I think that's what you're trying to get around is like, oh, that export failed for some reason. Probably we did something wrong,
It's not
right?
necessarily the export failing. Like if I would be redoing it, I never really had issues with the exports themselves. So actually, I think that's happened once, but typically
Okay.
it's the model itself failing. So I restart that
Oh,
job itself rather than just the export.
okay. So you want from here just being able to click and say export.
Yeah, or like let's say I load up. I typically run 4 models at once. Let's if it fails, I'll just try running the exact same job again, but in the time frame it'll still populate on the calendar. So if like Professor Field mentioned, there's that drop down window like, oh, this is the latest run of this particular
Got it.
cavities.zip file that worked. I want to click that one because it's because let's say I do like 3 or 4 of them, but the latest one I knew works, so I could click on that one, then click, and then export that batch that you've selected.
Yeah, yeah, I love this. I've run into a similar problem. We can see it right here, right? This one here that was 6 images is actually two separate jobs of 3 images each. You don't want to export all 6 of them. You just want to export the 3 from that one particular job,
Yep.
is what it comes down to. Yeah, no, that makes absolute sense. Yeah, so we need to have an ability to, I guess, like group by job and have that be a way somewhere that we can export. So yeah, you put in the chat export by job. Now I know what that means. Because I was like, an export is a job. So all of these things here are a job in our nomenclature, but you're saying an analyzed job um, type of thing.
Yeah, and something to be able to sort the by latest by the
Hmm.
most images, right? Those types of things would be fruitful.
I
Yeah, we
think
have.
like in that case, the like if you had the timestamp of like when the you sent off your zip file or whatever for analysis, then you could see, oh, this is the latest temporally. Then I could export that one that worked, for example.
This
Yeah,
is
we.
this. I was going to say this is all predicated because we basically skipped the examine page, right? We're just doing all of the exporting from the home page.
Yeah, because you're just doing jobs. Everything is a job
Yeah.
for you guys right now. Yeah, that makes sense. Um, I think what we could do is in a more immediate something that could be done not today because it's already Friday afternoon, but we put a button here like next to the examine button, it's export, right? And then we can add more filters and more searching capabilities. So one of the things that we added recently is on the reuse, you can add a search term. And some of you maybe saw, if you're watching closely, I can say, okay, show me all my mask models, show me all my YOLO models in all this sort of case. If there's one that I know has a particular name associated with it, he's not on today, but Ian's situation, you can search for that. Being able to have that down here and do that for all of them would help at least be able to filter the analyze jobs. And then if there's a button right there next to the configure that's export in some way, shape, or form, I guess we can make it look like the download button, right? Because it's like, oh, okay.
That's what I put in the chat. I just said that. Just right next to the config wheel, right? Just put the
Yeah,
download button.
yeah. Yeah, that would be, and what we could do also is we could add to the zip file, if you do a zip file, add the analyze job configuration as a file so that you could then, so then you have like that traceability of what's going on in all of the systems then too. Yeah, I like that. We will add that as a feature request and we'll add that to this card. And I'm going to assign that to Ben and Daniel. Ben and Daniel are new to the world and to the system. So and also new to Theia Scientific, but they are also come with a lot of experience in programming and development. So feel free to reach out to them. They are on Slack, just like everybody else, and all of that. So we will make that a features to add those in, and then add in more search abilities and features in that regard. All right, so we can. There are no V9s. There's never any V9s. But cool. Yeah, those are excellent. So Justin, your problem with the that you sent me with
Yeah.
the exporting, if it's okay to share it.
Please go ahead. Yeah, because I was having
Yeah.
issues where Professor Field, please correct me if I'm wrong, but because you set up the JSONs, that we were doing different resolutions for four separate models on the same set of images. We did the YOLO V8, and then the Mask RCNN at 4K with and without Asahi, and then the 2K. For whatever reason, when I was exporting them, I noticed that when the images came up like this, for this example is the 2K Sahi. I had to multiply all my output by 4 for it to match the YOLO. And then for the 4K model, I had to multiply by 2, and then it matched.
Yeah, so I think what is going, so I think there's two issues. One is I think the DM4 files, we have a bug in our DM4 reading capacity, and it's using the wrong image width or image height, basically the wrong image size, and it's using the tile size instead of the image size when you're doing the tiling. But I have an issue. I haven't had a chance to fix it, but yeah, this was next on the list to fix after we figured out the Detectron 2 image size, image scaling thing, which hopefully is not happening anymore, right?
I was going to run them
Okay.
later. I haven't tried it yet.
Okay. Because that is an issue with the upstream project, but we sort of created a workaround within the code to have that work. But with that resolved, hopefully, I was going to move on to this, and I was going to put Daniel in charge of figuring that out. But Ben, you're also more than welcome to jump in and help if you want to, since you've been dealing with the distance stuff and working with all the image stuff on the back end. Um, but that was something because I think it's actually something with the DM4. So if you converted them and tried that same matrix, but with like in TIFF or in a PNG or even as a JPEG, do you see this problem? And that would be something to try. I know you already have a huge matrix of experiments and stuff to do, but as a more immediate workaround, you can try that and see if that would work. But
I converted everything to PNGs, and I was planning to rerun, but I wasn't able to before
okay,
the office hours.
okay, yeah, no problem. So yeah, I would think somewhere around there is the issues, and then if it is related to the tiling, then I'm guessing because it's only happening with the Detectron 2 models, right? Yeah, okay.
I think I'm not sure.
It happens with
Yeah.
YOLO too. We
Okay,
we
so
it's perpetuated for quite a bit of time.
okay. Then that sounds like it's tiling and in the Sahi and it's probably compounded because it's never just one thing anymore. Um, it's also DM4. So we just need to confirm that it's something, and I'm guessing it's the DM4 because most of our internal testing is done with just TIFFs or PNGs or JPEGs. And I did run these images and I did not see this problem. But then I uploaded a DM4 file and I saw the problem. So, but I ran out of time and didn't get a chance to confirm it was tiling and DM4 or just DM4. But yeah, we'll get that fixed. Cool. Other issues? Mhm.
I have one,
Yeah.
which is whenever you guys push an update, the GPU container never works. And even a remote boot doesn't make it work. So you have to do a physical reboot. So I don't know what's going on.
we know what's going on, and we have been struggling to figure out a way to make that not a thing. But that is one that is related to the GPU drivers, and unfortunately, we have had multiple GPU driver updates over the last several releases, which means that it appears that every release causes that, but that's only because we've been updating the GPU. If we don't update the GPU drivers, you shouldn't have this problem. But the problem has been caused because September is roughly the time when NVIDIA releases a bunch of stuff. It's September and March are their like big event time periods, and they were releasing a bunch of updates. We also recently moved from what we call this 570 family of drivers for the GPUs to the 580. And that was after we ensured that the 580 branch of the drivers worked with the hardware that everybody has. But one of the reasons we did that jump was because that gets you CUDA 13. And no one currently has a CUDA 13 model that we know of in the community, but I'm sure you're all going to do that at some point. So that's going to be a thing. Thank you, Wei Ying, for joining. And so we are trying to keep on top of all of the driver updates and hardware updates that NVIDIA provides for that. But yes, we are thinking of ways of fixing that. If you rebooted it, I can start it up again.
Yeah, I should have rebooted, but then another idea, right?
Mm-hmm.
Especially for things like Justin's working through, which is kind of you're working through a workflow that maybe is takes a week or two, right, to get through, just because you're collecting data and going through. It may be preferential not to update during that. So could there potentially be a button or something that you could just have that just stops updates, right? So you could get through a current kind of workflow, and then you could just either manually update or automatically say like, oh, don't update until end of December. Same thing that like Windows says, you must update this driver, and you're like, please don't do it for 5 weeks.
Right. Yeah, I think that should be possible. We need to look at the Balena supervisor API, and there should be a way to do it through a button that would be on. We would add it to the system dashboard, and we could put it over here, and under like device or something, we could have updates like turn off or something like that. Or for release, we could have a stop button that would be here.
You have the update panel in the upper right-hand corner. You could just have a toggle button that clicks, that flips over to auto update.
Oh, up here. What you're saying?
Yeah, right there.
Yeah.
Put it right here.
Oh,
toggle button.
Yeah, I can see it. Yeah. Yeah, we can go ahead and do that. We'll have to take a look and see. So if someone on the TS team could create an issue in Grafana to add that in. We may have to do that on the system repository, but I think the first step is to look and see if we can add that through the supervisor API in Balena and then go from there. We should be able to do that. I'm happy though that we have this problem as opposed to the other problem, right? We've gone from one end of the spectrum where you get no updates to any of your instruments. There's still that bug from 2001 in your microscopy software and your microscope control software, to now we're updating so fast that it's causing problems for the users. So I'm actually quite happy about that. That we at least have this workflow in place that we can do that and provide that in a way situation. So cool. Yeah, no, that's an excellent point. We don't ever want to. Well, I'm also happy that the system is stable enough that you can run for a week and not have any problems where you have to stop and reboot. Where the updates would be an issue. So that's great. Cool. So we're getting onto the hour, and I know others have to go and such. And also, I know that it is Friday afternoon for most people now, and we're moving on. So Just wanted to call out again, there's the microscopy hackathon. This is the link to it. It's from the University of Tennessee in Knoxville. The actual event is the 16th to the 18th of December, which is the week before Christmas, but that also might be the week of finals for some people. But there are a number of sites. Also, NC State is involved in it. And I believe Oak Ridge has some work in there as well. They have some international participants and such. We are sponsoring it. And so we just want to call it out and say if there's a team out there that needs the Theoscope to make this hackathon work, we would be more than happy to work with that team to make that happen and see that work. Also, if you already have a Theoscope and you are going to be participating in the hackathon, I just want to call out one more time that we do have onboard Jupyter notebooks to do those rapid development and prototyping right directly on the system for that to happen. So just to wrap everything up, we can please join our LinkedIn and follow our newsletter. I said those in opposite order. Please follow us on LinkedIn, join the newsletter. And then we also are available pretty much anytime via email for questions, comments, complaints, and concerns around there. And please do not hesitate for the feature requests and bug reports. We have a system in place to turn those around and get those resolved. So thank you. And I will give everyone one last moment to any last minute questions, comments, complaints, concerns before I call it a day.
Hi, I'm sorry, I just joined very late and I'll just take this as an opportunity to introduce myself. I'm Sirisha and I work at Oak Ridge, Oak Ridge National Lab in the CNMS division. I got excited when you talked about the hackathon. Yes, that's being organized at UT and I'm also going to participate there. Yeah, and I met your group actually at M&M conference
Oh, cool.
last July. Yeah, July.
Yeah.
Yeah, I had a poster about like I work on this very same YOLO models, but for bacterial images, not for this.
Oh, yeah.
Right. So we were kind of going through what I do and the kind of results we got and stuff like that. And then yeah, I came to your booth and I really had a good time
Oh,
looking at
great.
your. I'd be interested to know more about like do you actually do biological samples?
So we
Uh,
have tried to expand as part of the one of the four E's of our theme is expansion. So we were doing NDT, but we also tried to do bioimaging. We were working with a group at Oak Ridge that was doing the plant biology and the growth, and they had a system there. We tried to pitch for bioenergy applications to
mm,
the Department of Energy, a proposal on there. I also went out to the SLIS conference to look at bioimaging from an automation standpoint and kind of do that.
mm,
So we have tried some of those, and people do bring us at M&M, do bring us bioimages of cells and stuff. And there are models out there in YOLO, but also in other ones. I'm thinking of like Cell Pros. There's the whole cell paint thing that's a big deal that we have been sort of, we'll call it in parallel working with or tangential to it. We don't have a specific use case or a customer that has been doing bioimaging. At the most recent M&M, cryo EM seemed to be sort of the main theme on that. And we were at Oak Ridge, oh geez, was it last year or 2 years ago? And we did some cryo EM images
Oh, yes,
on
those are
Texas.
cryo-EM images. Sorry to interrupt you. The ones that I have used to build my models, and
Mhm.
we're actually developing it into a patent. Let's see what
Mm.
happens about it. But we just submitted it, and we are, I don't know. This is my first patent in my life, so I don't even know what
Oh,
that means. So, yeah, but the results seem to be quite promising. That's the work actually I was showing at M&M.
oh, cool.
So yeah, and so I was like, so I'm basically a biologist, by nature. until I joined Oak Ridge, I joined Oak Ridge like last year.
Mhm.
I have done AI applications majorly for proteins and drugs and drug discovery, target identification, and stuff like that. And then when I jumped on to, I needed a little bit of image analysis kind of a thing. And that's kind of hard to do when you have smiles and sequences, It's kind of,
Yeah.
it doesn't fit in this domain. You have to work
No.
with images as such. So I took
Yeah.
up the position. I'm sure you are familiar with Alexis. No? Okay,
Alexis
she's
or
Alexis. She's the one who works, she's in charge of the cryo-EM facility. So she's
she
the one
may
who
have been
works
there
along with
at
me.
that. That was again, that was like 2 years ago, I think.
Oh, yeah,
Uh,
yeah, yeah. Okay, maybe she wasn't there by then. It could be.
yeah. Yeah.
So,
Yeah.
yeah, so I was trying to, the reason I joined this meeting was because you guys deal with the exact same models that I am.
Mhm.
And I'm also looking forward, like, I'm also looking forward to see what other applications and what other opportunities I would have. It's interesting that something
Yeah.
that we've been doing at Oak Ridge is actually being implemented in industry. That's a very positive sign for me.
Yeah, we support YOLO, SAM, RCNN through the Tektron, all of these different formats, and any other models that people are PyTorch based, we can support and implement as needed from there. But yeah, we also have worked with Oak Ridge, and we've been out there for the nuclear materials area and such. And Kevin, who's on the call, used to work at Oak Ridge, so we've been out there and
Okay.
have um, been out there a couple of times. And then we also have a Theoscope deployed at the University of Tennessee and Khalid Hattar's group.
Hmm. Okay.
So if you want to drive over and if you reach out to him, you can check
I
it
was there
out in that
yesterday.
regard. Oh, there you go. So yeah. And then yeah, that's great. Yeah, thanks for joining. And it was great that you stopped by the booth and during M&M and that you came by today. And good luck in the hackathon, and we'll see how that
Yeah,
goes.
absolutely. I hope so. And yeah, I'm reading the message in the text box. Yes, I do have my YOLO models already running.
Oh,
Kevin, thank you.
Yeah, yeah. You can load them up actually into if it's a YOLO, any of the variants that are supported,
Yeah,
you can
it's
load it up and
YOLO 12, 12, 11, 11.
11 should
11
load.
is, yep, 11. If you have the WAV files, you can
Yeah, I
upload the
do.
WAV
I do
file
have.
and yeah, and off you go.
I mean, Chris,
Mm.
if you wanted to, right, Chris could, you could send it to Chris. You could load it up on it and show you what it would look like with the Theoscope. I don't know if we want to do that right now, but we could do that at a separate
Yeah,
time.
yeah.
Not right now, but I'll look into it and send it over to Chris.
Sounds great.
And thank you, Chris, for accepting my LinkedIn request
Oh
yesterday.
yeah, yeah, yeah. You're welcome.
Thank you so
Not a
much.
problem. All right. Well, thank you for joining, and thank you everyone else for joining. Have an
Hope I
excellent
see a
weekend.
bunch of you guys at the hackathon.
Yeah,
Yeah.
yeah. Have a great Thanksgiving, everyone. If I don't see you before then, have a great weekend. Thank you all for joining, and we'll be in touch.
Absolutely. Bye bye.
Bye.
Bye.